Good morning, geometry classes. We're going to take a look at our 10.6 samples. We're looking at determining segment lengths of chords inside of a circle as well as segment lengths on tangent or secant segments relating to a circle. All right, let's take a look at sample 1 to find out how long x is. So we notice that we have the following markings. We have this chord split up into two segments from here to here, 8, from here to here, 10. And then this chord again is split into two segments, x long and 9 long. So that point of intersection separates each of those chords into two segments whose lengths are labeled, and we're looking for the length of x. That's this segment right here. The relationship between those two chords and their segment lengths is the product of the two segment lengths is equal to the product of the other two segment lengths on those chords. So we can say that 9 times x, right here, is equal to 8 times 10. And then we're going to solve that equation for x. We will divide both sides by 9, and we're going to show our work over here. If we want, since we are needing to work out 80 divided by 9, here's our work for 8 and 8/9 written as a mixed number. Now, it wouldn't be wrong if you reported x as 80 over 9, as long as that improper fraction is fully reduced. That would be a correct way to report your result. However, since this is a measurement, we're trying to figure out how long that x is, the way that makes most sense is to show your final value as a mixed number or as a decimal. That's typically how we show measurement. All right, sample 2. So on sample 2, we're going to take a look at what is the value of x in this diagram here, where we have a tangent segment and we have a secant segment. So the relationship between these segment lengths are, if you take this tangent segment and square it, it will be equal to the segment from the point outside the circle to the circle, so 4, times the entire segment from the point outside the circle to the side of the circle here at the end. All right, so we're going to write 4 times 4 plus x, 4 times the entire secant length, 4 plus x, is equal to this tangent segment squared, 12 squared. All right, and now we're going to solve for x. So using the distributive property, we have 16 plus 4x is equal to 144. Subtract 16 on both sides, and 4x is equal to 128. Divide both sides by 4, and I'm showing my work over here. That's not necessarily the case that you must write that down, but it's an easy way to get your 32. Or just think 4 goes into 12 3 times, no remainder. 4 goes into 8 twice, no remainder. So x is 32, and that is the length of this segment here. All right, sample 3, which will be our last sample for this lesson. So on this one, we have two secant segments, and the relationship on those secant segments is the length of the segment from the point outside the circle to the circle, 5 in this case, times the entire length of that secant segment, 5 plus 3. So here we have that, 5 times 5 plus 3. That's going to be equal to the other secant segment, 4, the outside segment, times the entire segment, x plus 4. So here we have that, 4, the entire outside segment, times all of it, 4 plus x. All right, now we solve for x. That will give us 16 plus 4x is equal to 5 times 5 plus 3 is 8. And then we're just going to rewrite this, multiplying out the 5 times 8 is 40. So 16 plus 4x equals 40. Subtract 16 on both sides, and we'll have 4x equals 24. Divide both sides by 4, and the length of x would be 6. That completes all of our sample problems here for this lesson. So now it's time to make sure this is in your notes on your lesson, and it's time to proceed and move on to the quiz for this lesson. All right, we'll see you next time.